Today we're going to work on Chapter 7, Section 7, Perimeters and Similarity. You're going to need to take out your video worksheet in your notes packet. We're going to skip over the opening problems and go straight to the new material. Okay, so you can do the openers on your own time. You can pause the video and work on them now. And I'm going to talk about the terms, definitions, and diagrams section. Okay. The point of today's lesson is to talk about the relationship between the sides of similar triangles and the perimeter of similar triangles. We know from the past few sections that if two triangles are similar, then their corresponding sides are proportional. It turns out that in addition to their corresponding sides being proportional, their perimeters have that same ratio. Okay, so just a quick review, if triangle ABC is similar to triangle DEF, like in the first example, we can set up ratios comparing their corresponding sides. I would say the best way to do it is to focus on the similarity statement. So if AB is the top of that fraction, then DE would have to be the bottom of the fraction, because those are the first and second letters of that first part of the triangle similarity statement. Okay, so I'd put DE on the bottom of the fraction. The second ratio starts with AC. Now AC are the first letter and the third letter of the triangle on the left, so that has to go with DF, the first letter and the third letter of the triangle on the right. Okay, and then the last pair is BC. BC is letter 2 and 3, so that's got to go with EF, which is the second and third letter of the triangle on the right. Okay, it's much easier to use the triangle similarity statement than try to look at the two triangles and compare them and see if one is turned or flipped or if the orientation is different. The triangle similarity statement will always have the letters in the right order for comparison. Okay, go ahead on to the next one. This one gives you some new information. It says the perimeter of triangle MNO is 13.5. Well, you could figure that out just by adding up the sides, but we'll go with it, 13.5. The perimeter of triangle RST is 9. The other part of information that it tells you is that triangle MNO is similar to triangle RST. Okay, that's important for this problem. What we had to do was find side X, side Y, and side Z. Well, the important new bit of information is that the ratio of the sides of similar triangles is the same as the ratio of their perimeters. So if the perimeter of triangle MNO is 13.5, then that's going to be the comparison ratio I can use for the sides. The perimeter of triangle RST is 9. The ratio of sides has to be 13.5 over 9. Okay, so say I'm trying to solve for side X. I'm going to start with that ratio, 13.5 over 9. X is side SR, which has to be similar to NM, which is the 3. Okay, so if I do 13.5 over 9, then I have to do 3 over X for the rest of my equation. Now, just simple cross multiply and divide. Cross multiply gets me 13.5x equals 27. If I divide by 13.5, I end up with x equals 2, and I can write it on the line. Okay, my next equation is going to start with the same basic ratio, 13.5 over 9, but then the right side, say I'm trying to find y. Y is between S and T. Based on my similarity statement, that's got to go with NO, which is 6. Okay, so my other side of my equation becomes 6 over y. Once again, cross multiply and divide. 13.5y equals 54. Divide both sides by 13.5. If you want to use your calculator for this, that's great. 54 divided by 13.5 is 4. So I can just write down y equals 4. Okay, and then my very last equation is to find side z. Use the same ratio, 13.5 over 9. The side z is compared to the 4.5. So I want to write 4.5 over z. And then cross multiply to find z. 13.5z, 9 times 4.5. Type that out. 40.5. And then if I divide both sides by 13.5, I end up with z equals 3. And that's my final answer. Okay, so I can use the ratio of the perimeters to find the ratio of the sides, and use that to find any missing sides. Okay, go ahead and check out the next problem. Looks like this time we've got two quadrilaterals that are similar. It says find the scale factor from GEOM to MATH. Okay, the scale factor is the number or fraction you would multiply the side of one shape by to get the corresponding side of the other shape. So I want to find the scale factor. I need to take a side of MATH and divide it by the corresponding side of GEOM. It looks like MATH, the side that's labeled, is the 24. And it's corresponding to the side that's 20 on GEOM. Now that's not my final answer though. If I want to write down the final answer, I actually have to simplify that. These are both divisible by 4. So I divide the top by 4, divide the bottom by 4, 6 over 5. That is my scale factor. Okay, 6 over 5 is going to be used for part B, where I'm trying to find x. I know the ratio from MATH to GEOM is 6 over 5. And I know the side that corresponds to x is the 18. So 6 over 5 equals 18 over x. Cross multiply and simplify. 6x equals 18 times 5, 90. Divide both sides by 6. 90 divided by 6 is just 15. Okay, let's go check out part C. It says we're trying to find the ratio of the perimeter of MATH to GEOM. Well, the perimeter of MATH to the perimeter of GEOM is going to be exactly the same as the ratio of sides. Okay, the ratio of sides we actually figured out back in part A was 6 over 5. That doesn't change when you're talking about perimeter. Okay, and I can use that ratio to figure out part D. If the perimeter of MATH is 96, find the perimeter of GEOM. I want to stick with that same ratio, 6 to 5. And then the perimeter of MATH is the 96. The perimeter of GEOM I'll just call x, and then I'll cross multiply and solve. So 6 times x is 6x. 96 times 5, that's probably a calculator one. If you type that in, you should get 480. And then divide both sides by 6. X equals 80. Final answer. Okay, x refers to the perimeter of GEOM. Okay, let's slide down and check out the last problem on here. It says the perimeter of triangle XYZ is 65 feet. If triangle ABC is similar to triangle XYZ and the scale factor from ABC to XYZ is 3 over 2, find the perimeter of ABC. Okay, when it says the scale factor from ABC to XYZ is 3 over 2, that means the ratio of the sides on triangle XYZ to the ratio of the sides on triangle ABC is 3 over 2. Okay, that's my scale factor. If I wanted to go from a side on ABC to a side on XYZ, I'd have to multiply by 3 over 2. That's what I'm going to use to find the unknown perimeter. So I'm going to use 3 over 2 as the ratio of XYZ to ABC. I know XYZ is 65 feet for the perimeter. That goes on the top because XYZ was on the top of the fraction over here. And then what I'm trying to find is the perimeter of triangle ABC. I'm going to use a variable x. In order to solve for this, I have to cross multiply. So you get 3x equals 130. Divide by 3. And you get x equals 43, we'll round, 0.33. What that means is that's the perimeter of triangle ABC. Okay, so the main purpose of today's lesson was to show you that the ratio of the perimeters of similar triangles is going to be equal to the ratio of sides of similar triangles. So if you know how the sides are compared, what fractional difference there is, then you know how to compare the perimeters as well. Thanks, have a great day.